All right, so today we are going to code the Vigenere cipher. And so yesterday you should have completed a worksheet, read through the notes, got an understanding of what the Vigenere cipher is. Today we're going to try to code it together. So the first thing I want to say is if you want the challenge, so the Vigenere cipher, it's a lot more challenging than the Caesar cipher and the substitution cipher. But if you want the challenge, you do not need to watch the video. You can go ahead, copy the starter code from Canvas and try it out. All right, you can always come back to the video if you get stuck. But if you were able to code the Caesar cipher and the substitution cipher and you feel like you're getting it, absolutely go for it. Okay. However, if you were a bit challenged by the Caesar cipher and the substitution cipher, you're still welcome to try out the challenge. But for us, I'm going to make a video here about how to do it. And you can just follow along, type it in as you go. A couple times I'll pause and ask you to try to finish that line of code. But aside from that, you're welcome to just kind of fill in the rest of the video with me, or fill in the rest of the code with me. All right. So we're going to start here. This is sort of the steps, the breakdowns on how to code just the first letter. And we did this before with the Caesar cipher on just coding the first letter, so then you can build a loop to do the rest, creating an algorithm to code every single letter. All right, so this is what you did yesterday on your worksheet. So the first was you had your plain text. You found where in the alphabet the plain text was, all right? Or the first letter of the plain text, you found where it was in the alphabet. In our code, we're going to refer to that as our P index, plain text index. Then you found the alphabet index of the code word, so we'll call that C index. So you had two indexes that you were working with at the same time, the one from the plain text, one from the code word. All right, once you had both of those, you added them together. That became your new index. Once you had that new index, you were determining which character in the alphabet had that index, and you added that into your ciphertext. All right, you continue doing that for the rest of the message, and then you had your Vigenere encrypted message. All right, so these are steps that we kind of know how to do. We've done most of these already. We know how to find the index of something in the alphabet. We know how to add two variables together, and we know how to find a character using its index in a string. So again, if you want to pause and try it out, you're welcome to do so. Even if you can get that first letter to work, that's awesome. The first letter is actually not the hardest part. There's other pieces that come with that as we get further into it that we have to kind of think about together. All right, so if you do want to pause, you want to try to just make these 5 steps happen, go ahead, and then you can come back. Okay? We're going to get started though. So in Canvas, I have posted up this starter code for all of you. I'm going to go ahead and copy. You don't have to copy this comment. This is just telling you what the code is. I'm going to just jump down to the alphabet, copy that over, and then here is the code. I'm going to zoom in so you can see it nicely. Okay. Should look pretty much the same as what we've seen already. We've got our alphabet at the top. We've got our encode and decode subroutines set up for us with our arguments. And we've got our test for hello world. Our key here is going to be code. If you want to switch out the message and the code word with the ones you came up with yesterday, you're welcome to do that, or you can test it out later. And then everything is set up for us to be able to test this out and see how it works. Okay, I'm going to add a space here. All right, so we are going to go ahead and get started. We are going to follow those exact steps that we had before. Some of our setup is going to be similar to what we did together with the Caesar cipher. So for me, I like to start with the first character. I need to get that first character. So what I'm going to do here is I'm going to define first character. All right, this is going to be the first character of my plain text. So maybe I'll call it first character P. All right, this is going to be plain text, square brackets, 0. Okay, hopefully you remember that that's your way to get the first character. I'm going to leave some comments here as we go. All right, you don't have to bring these in, but just as you're watching so you can keep track of all the steps we've done. All right, so first character of plain text. And for us at the moment, that's H. H from Hello World. Okay. If I was working on the worksheet, all right, I would fill in the letter H, and working down, the next thing I would do is I would find where is that in the alphabet. All right, so I said I would use P index to indicate that that's the index of that plain text character. All right, If you want, you can pause it for a second, see if you can figure out how do we find the index of this character in the alphabet. I'll give you 2 seconds to pause it, and then I'll keep going. Okay, so the way that we get this index, we're looking in the alphabet. So we say alpha dot index, parentheses, and then I'm saying, what character am I looking for? I'm looking for whatever that first character was. All right, so I'm going to say first character P, and then there we go. All right, first character P we know is H, but if I switch that out with any other code, then it could be whatever that first character is. Okay, I'm going to add a comment here. All right, this is index of first character, first plain text character. Okay, and if I count through the alphabet, that's going to be 7. Okay, 7 is the index of the letter H. Okay. All right, working down our worksheet. If you have the worksheet in front of you, that would be really helpful. If not, I'll just tell you what comes next. We have our character. We found it in the alphabet. Now we look for the code word character and find that in the alphabet. So this is going to be the first character of the code word. I'm going to use CW. Okay. All right. Based on the code we already have, you should know how to find the first character of the code word. So you can go ahead and type that in. I'll give you a second. Okay. Hopefully you got it. It should be code word, square brackets, 0. Okay, exact same code that we have in line 4. We're just using it for the code word instead of the plain text. So first word of code word, first character of code word. Our code word is code. So the first character should be C. Okay. Okay. The next thing on your worksheet was to find the index of that character. Again, pause it, see if you can figure out how to do that. We've already done it for the plain text, so see if you can do it now for the code word. This is where you can pause it if you want, but if not, I'll fill it in for you. All right, C index. All right, I'm actually going to call it CW index for code word is equal to alpha dot index. All right, but this time instead of first character P, it's first character CW. Okay, and then this is the index of the code word character, the first code word character, which if this is C, starting at the alphabet, that's 0, 1, 2. So that should have the value of 2. Okay, so if I was filling this into the worksheet, I would have H, then 7, C, then 2. All right, the next step on your worksheet was then to add your indices together. I'm going to call this index total. That's the same thing it was called on your worksheet. All right, I'll give you a moment, see if you can finish up that line of code. This one you should be able to. You're adding your 2 indices together. Give me a moment. Okay. I'm adding index from the plain text. I'm adding the index from the code word. This is P index plus CW index. That's it. You're just adding them together. Okay. Because we had 7 and 2, this should hold a value of 9. 7 plus 2 is 9. Okay. And so this is going to be the sum of the indexes or indices, which is 9. Okay. All right. Done, 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 done. We've got the sum of both. Index total is going to be the new index for your new character. So this is time now for us to find out what is the new character that we get when we add H and C together. All right, so I'm going to say new character is blank. All right, and again, I really encourage you to see if you can figure out what this code is. Anytime that you're looking for a specific character, if you know the index. All right, we're looking in the alphabet, and we know the index is 9. How do you get the 9th index of the alphabet? All right, you can go ahead and fill that in. Okay, if you need more time, you can pause it. If not, this is going to be alpha square brackets 9. Okay, however, because we don't actually want to put 9, we want to say the variable index total. Okay. All right, and then this is going to be new character from the, actually, no, I'm just going to call it the new character. All right, your new character in the 9th index. All right, well, we know H is 7, so 7, 8, 9, that's going to be the letter J. Okay, so we get J. Okay. For now, all right, if I just want to see if this works, I'm going to return the new character. All right, ultimately, I want to return the entire ciphertext, not just the one character. All right, but we want to see if this works. It should return the letter J. Fingers crossed. Let's see what happens. Here we go. There's J. So it worked. All right, that's great. I'm super glad. Our next part is kind of the tricky part. So these pieces are all pieces that we've worked before with. So finding the index, adding things together, getting a character from a string. The tricky part is going to be making this loop, right? And making it work with all of our letters, not just H and C. Okay, so first thing I'm going to do is something we did with all of our other ciphers so far. I'm going to set up a ciphertext string. So ciphertext is equal to empty quotation marks. And at the very end, I want to return ciphertext, not just the one new character. Okay, so these two lines, line 4, add in your empty string. You can add as you go through. You're going to add every character to that string and then return the string at the very, very end. Okay. We want to add a for loop here because we want to loop through our entire word. Our for loop is going to be a little bit different than the ones we did together because we have two words that we're looping through. We're not just looping through all the characters of plain text, we're also looping through all the characters of code word, which are two different characters for the most part. All right. What we do have in common here is we're looping through the same index. So when I'm looking at the first index of plain text, I'm looking at the first index of code word. When I'm looking at the second index of, yeah, you get the idea. The second index of plain text is the second index of code word, and so on. So they have that in common. So instead of saying for I in plain text, all right, I want to say for I in something that they both have in common. They both have an index in common, 0 and 0, 1 and 1, 2 and 2, 3 and 3. Okay, so instead, I'm going to use a range of numbers rather than the individual characters of plain text. All right, this bit's a little bit abstract, so if you need to pause, take a moment to let it sink in, think about it, that's totally fine. Okay, but really what we want this to loop through is our first indices, and then our second indices, and then our third indices, and then our fourth indices. All right, we're looping through numbers, not characters. Okay, so instead of for I in plain text, I'm going to say for I in range. All right, anytime you have a for loop in a range, it's starting at 0 and it's just counting its way up, okay? The number of times I want this to loop is however many letters are in my plain text, which for hello world is 10, but for any other, it depends on the length of that string. So we're gonna say for I in the range of the length of our string, which is plain text, okay? We know that plain text is, or the length of plain text is 10, so this is really saying, oops, for every number for I in the range 0 through 10 or 0 through 9 because it stops before 10. So this is going to loop through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 loops. Okay. I'm going to take everything we did and indent it into that for loop. Okay. The only other thing at the moment that I need to add in is this new character. We're not doing anything with this new character at the moment. All right. And actually, if you click on it, it says new character is assigned, but it's never used. All right. We need to save that new character to our ciphertext. So this is the same code we used in all of our other ciphers. We're going to say ciphertext is ciphertext plus new character. Sorry, I blanked for a moment. New character. Okay, so we're taking whatever that new character is, we're adding it into the ciphertext. It's going to loop 10 times. It's going to do all of this 10 different times for each individual character, but each time that new character gets added in to the ciphertext. Okay? So something that's going to happen here, because I need to fix a couple things, is if I run this, we're going to end up with 10 J's, all right? Because what we haven't done is we haven't updated what index we're looking at. So this is saying 10 times do this with the first index. So do H, do H, do H, do H. We get J, 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 J. All right. We want to change 0 after our first loop to 1, and then we want it to change to 2, and then 3, and then 4. That is the value that I takes on as it loops through the range, all right? And so instead of saying for I in range do plain text 0, we're going to say plain text I, code word I. Oops, I. Okay, so the first time it loops through, I is going to be equal to 0. Then I is going to be equal to 1, and then 2, and then 3, and then 4. And it's going to keep looping all the way through that range up to 9. Okay, this is kind of what we want. This will work in some contexts, but there's a couple things that we have to make adjustments to, some things that you saw on the worksheet yesterday. Okay, the first is my key is 4 letters and my code word, or sorry, my encryption is 10 letters. All right, and so if you remember what you did yesterday, what you did was you just repeated the code word however many times to something like this. All right, like code, 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 however many times until it fits the same number of characters that we have here. This is okay to do it this way, to just say your key is code, code, CO, all right, however many letters match up with hello world. But it would be better if we could code it so that the user, or whoever is using this, can just enter in whatever their plain text is, and they can just enter in their code word, and they don't have to worry about typing it in a weird way like this. They can just say the code word is code, all right? So the way that we do this is we consider, well, what's really happening here? All right, we are going from 0 to 9 in hello world, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You get the idea? All right, whereas code only has 4, so it's only going 0, 1, 2, 3. All right, instead of running out of characters when we run this program, we want it to go back to the 0th character code for C. All right, so we want it to do 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, and it continues on and on and on. What we're doing is we're looping through numbers 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. And I mentioned the other day that when that happens, you use modulus. All right, modulus is all about looping through numbers. So instead of saying code, 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 I'm going to leave this as code. But here, where I'm talking about the index of my character or of my code word, instead of going all the way, because I is going to go all the way from 0 to 9, I'm going to say do I mod 4. So it's looping through 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So if we get past 4, which we are, because we're going all the way up to 9, it'll start looping back. Okay? So that is a tricky piece, all right? If you are one of the people who paused, tried to do it all on your own, and then had to come back for this piece, that's totally fine. This is a tricky piece to try to work out. But if you also did code, 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 that's okay too, okay? One more thing, one more piece to figure out, all right? I'm not sure if this works without fixing this last piece. We'll run it and see. Yeah, okay. So we can see that I have this error here, error here. Everything else is fine except it's saying that something's happening here where our string index is out of range. We saw this before. All right. You might have seen this on your worksheet where you added 2 indices together and it exceeded 25. All right, so we ended up at 25. You had to subtract 26 to work your way back or loop your way back through the alphabet. All right, again, anytime we're looping through numbers all the way up to 26 or 25, we loop back, all the way up to 25, we loop back. We're using modulus. All right, so it's a small piece, but right here where we're adding our 2 sums together, when we add them, we want it to loop back if it's greater than 26 or 25. All right, so we're going to say mod 26, which means that if we go past, if we end up at 26, it loops back to 0. If we get to 27, it loops back to 1. Okay, so just these 2 pieces of modulus, which are a little tricky to come up with on your own, especially because it's not something we're super familiar with, but that should work. Okay, I'm going to run it. I'm going to cross my fingers and hope that everything turned out the way that it was supposed to. I believe the first characters are JSO or something like that. So let me close my console, run that. JSO, there we go. JSOPQKRVNR. Awesome. That's what we want. Okay. I am going to task you with trying to figure out the decode. All right. Very, very similar to the previous problems. You want to just work your way backwards. Okay. You don't have to mess with the modulus. The modulus can stay as it is. So these pieces of code here, you do not have to change. Okay. What I would suggest that you do is the same thing as before. Copy and paste this below. Okay. I would switch out ciphertext and plain text. All right. You want to be building your you want to be building your plain text. All right. So anytime you had ciphertext, you want that to now say plain text. All right. And anywhere you had plain text, you want that to now say ciphertext. All right. Ciphertext, plain text. I think that's all of them. Okay. The only other thing you might want to do, and actually these plain text should be ciphertext, first character of ciphertext, ciphertext. Yeah. The only other thing you might want to do is change first character P to first character C because it's the ciphertext. But if you don't want to be that nitpicky, that's fine. All right. So think about it. Again, work through each line, see what each line is doing, and think about how would you reverse it. If it helps, you can go back to the worksheet from yesterday and think about how would I decode this? How would I work my way backwards? And see if you can figure it out. Okay, you're welcome to work together and talk about it, but see what you can do. Until next time, I hope you have a great day, and I miss you guys a ton. I'll see you. Bye.